Hi, I'm Philipp. We are going to talk about the Elastic Stack, or how I'll call it, it's like logging all the things, logging all the metrics, like all the things. So I work for Elastic. I'm in the infrastructure team, so we provide Jenkins, Docker, AWS, Ansible scripts, Puppet, Chef, everything you're doing on the infrastructure side, and I'm kind of piping that activity into developer advocacy, so I'm out and giving lots of talks. So, who is already using Elasticsearch? 3, okay. Okay, I guess the numbers for Logstash and Kibana won't increase. Anybody using Logstash and Kibana already? No, okay, 2. Beats? Anybody heard of Beats? No? Okay, good. So I can talk about all the things and you have no clue. So, who was there at my first talk today about Elasticsearch? Okay, good. So I guess everybody knows what Elasticsearch is. You can store stuff, you can search for stuff. It can do different stuff than databases. These are some of the guys who are using Elasticsearch for full-text search. So yeah, I guess no further explanations are needed there. And then we have Kibana. Kibana is kind of the window into your data because what I've shown you in the previous talk was very much, okay, I could have used the shell with curl or any other REST interface, but I was already using Kibana with the thing I used is called console. You can easily query stuff, but you can do much more with Kibana. I can actually show you, just to give you a quick example of Kibana and show you something. So where is my mouse? So I have, so this is Kibana. This is the upcoming version 5. This is currently Alpha 3. It's already working pretty well, so I hope it doesn't crash during the demo. What you have here is, first starting off with console. Console is what I've been using in the previous demo. It's just like a nice interface, so you can write stuff and it actually knows what you're doing. So you have syntax highlighting, you have autocomplete, and it will tell you if you're doing something wrong. So I have one node, and I'll just add the column there. So I have my one node. It is called Icarus. Every time you start up an Elasticsearch node, it will get a random name from a Marvel comic hero. So every time you start up the node, it will be another hero. But you can, of course, configure it. As I said, this is Alpha 3. So in this, oops. What? Yeah. So we don't have, so we are already ingesting some system level metrics. I will show you that off later on. But I will now insert some actual data just like your application would do. So I have a little, this is really small, but you don't really need to see so much. What I want to do is, I have a jar file. No, this was the wrong usage. I have a jar file that will insert randomly generated data for me. I'll just say I'm inserting 100,000 data sets in batches of 10,000 elements. On top you can see one example document how it would look like. So all the documents have a name, so these are persons. Name, the birth, the gender, how many children they have, some marketing information, and an address. And so my inserts are running, and when I run this query again here, there should now be person, and you can see, okay, this is my person index. It is running, it has currently 23 megabytes, and I have inserted my 100,000 documents already. So in Discover, I can then switch. Discover is to discover your data. Little surprise here. You actually see over whatever time frame you have selected. So I've picked the last 100 years here, or like when I'm a people born, like I think like 80 years would be enough. So I can quickly just get all the people. You can see they are randomly generated but pretty even, and then down here you can actually unfold one data entry and you can see, okay, these are the people I have in my data set. And now just to get to the exploring part, I can on visualize, I can say, okay, I want to know, for example, from which countries do the people come from and how is the data distribution. So I could use a pie chart, for example. So I'm going to a pie chart, I select a person, and I say, okay, what I want to do is I want to aggregate over a term, and the term I want to aggregate over is the address country. And when I run that, up here I have my run button. You see, I'll make this a little smaller. You see, okay, obviously my people are just being generated from 4 different countries, and they're pretty even, though since they're randomly generated, they're not entirely even. So the country with the most people is, I think, England, and Germany, they're the smallest one. So those are the people from England. And then you could actually say, but I want to explore my data further. I want to add a sub bucket here, and I say now, I want to know, again, I want to filter on terms. Now I want to know from which cities these people are. So I can select the city here, and I can run that again. And then you can see, okay, these are all the people from England, and these are the cities they are from in England. So you have people from Plymouth, which is obviously the biggest city in my data set, then London, then Liverpool. And you could drill down further the data, and you can somewhat change that here. For example, if I want to have that as a donut-shaped visualization, I can simply say it like this. And then I could, for example, add another sub-bucket, and I could simply say, yes, I want to split this further. And I want to say, okay, I want to filter on the gender. And then you can actually see the male-female distribution for each city. So you can see all the females and the males from Plymouth, and you can drill down there. So you can go pretty far with all that data visualization. Or you could just say, I want to know where are the people actually from. So then you can say, okay, I want a tiled map for the persons again. And then you just say, yes, I use geocoordinations, and I have an address location. It figures that out already by itself. And then I can simply generate that. And when I zoom in a little, you can actually see, okay, where are the people from? And if you zoom in much further, you can see, okay, I think Plymouth was my most populous city. And if you all have all of that information, you can see, okay, actually my test data replication is not that clever. Okay. I won't touch anything. And you can just see, okay, my test data generation is not that clever. It just picks a random square and generates all the people in there. But yeah, you can see the use case. If you wanted to write a dating app, you could just simply get all the people from within the same region and order them by their gender and do all the regular stuff and just visualize stuff easily. And of course, you can do the same things for stuff like server logs. Like, where are my visitors coming from? What are the status codes my logs are giving you? And this is the second use case. So we had Kibana to visualize data. And the second thing then is Logstash. Where are the people coming from, or where are the logs coming from I want to analyze? And Logstash is just picking up there. So we're pretty relaxed about programming languages. Elasticsearch itself is written in Java. Kibana is by now a Node and Angular app. And Logstash is written in Ruby. But for performance reasons, it's now JRuby, so you have the JVM and you run just Ruby scripts inside it. And you have like 200 plugins, and you can ingest data from various different sources. So for example, what we could easily build is, for this conference, we could could just aggregate all the tweets, since there is a Twitter plugin. You can just ingest all the tweets, and then you can see, okay, who posted the most tweet with the today JavaDay Lviv hashtag, and when did people most tweet, and how many tweets did we get in the entire day, and you could analyze all that stuff. But that's not limited to social media. Social media just always a fun example. You could also ingest your log files and then parse them. And then you can do some enrichment, like you can just, from your web server logs, you might have an IP address, and you would want to know where is that person actually from. And we have the integration into a geodatabase, and then you can simply look up that IP address is from that country. So this was, I'm explicitly saying was, called the ELK stack. So Elasticsearch, Logstash, and Kibana. And this is the ELK, and we even had a little toy with the ELK, and one of my colleagues is still carrying around the ELK to conferences, but I'm always forgetting my ELK at home. Also because the ELK has been retired. Yeah, so first off, these are big companies using the ELK stack. So for example, CERN, they have lots of servers to analyze all their data. I think they have thousands of them. And they need or want one single place where they have aggregated all the log files. And they're using the ELK stack for that. And then there is Salesforce. They're the cloud provider doing tickets, sales leads, all these things. And again, they are aggregating all the data and storing it in the ELK stack. Since it's very easy to ingest data, store it, and then query and explore it. And Goldman Sachs has a slightly different use case. They have the use case that they're often doing something wrong, or like, yeah, screwing up a little bit, and then they need to pay big fines. And every time they need to pay, I don't know, like a $50 million fine. At some point they decided maybe we should try to avoid paying the fine, and we could invest like 5 million into proper auditing and compliance rules to avoid paying the fine next time. And that's what they're using the ELK stack for. So they have very big clusters, and they're just ingesting all the different things people and systems are doing, and then they try to avoid doing the bad stuff. So this worked out all very nicely, but then this little fellow came along. This fellow is called Beats, and is kind of complementary to Logstash. The problem with Logstash is it's JRuby, and since you have the JVM, you probably don't want to put that on all your servers. So if you have one server for static files, or you have a database server and all these different servers, you probably don't want to put the JVM on all those servers and then have JRuby running, because it always takes some time to start up. It needs quite some memory, and it just feels a bit slow. So what Beats does is, it tries to take over some of these features, and it is written in Go. So you have native system binaries that can be very efficient, and if you start Logstash, it will take, especially on a VM, it will take 5 to 10 seconds, and Beats, even on a VM, will start more or less instantaneous. So this led us to the naming problem. ELK stack, what are we making out of the ELK stack? So we tried with ELK B or BELK, and you can see, okay, it's a B and it's still part of an ELK, so it has the ELK horns. So this was the BELK or the ELK B, but at some point marketing kind of decided, nah, this is not really cutting it, we want something else. So they were rather uncreative and said, okay, we are just renaming the stack to the Elastic stack, which makes it also easier, because in the future we can just say, hey, we have another product, we simply add it to the Elastic stack, it's still called Elastic stack, we don't need to find another made up animal. And this is what the stack actually looks like. So you have the beats. If you have seen the logos before February, they were different. Like the stack has been growing organically. So Elasticsearch has been the first product. Also in the beginning, the company was called Elasticsearch. But then Kibana and Logstash were acquired. They had different logos, like you saw in the beginning, like Logstash had this wooden log, and Beats as well. And so it was then decided, like, doing a rebranding, just getting one corporate identity, and now this is what it looks like. So we have Elasticsearch, where your data is stored and searched. We have Kibana, standalone application that can query your stuff. We have Logstash to do the enrichment, and we have beats. Beats are kind of lightweight forwarders. They're very much built for one specific use case. So you have, for example, FileBeat to forward files. And they can simply forward stuff either directly into Elasticsearch or into Logstash, so that you can do some further enrichment here. But this is a very common question, is Logstash going away? Not at the moment, I don't think it is going away, it's just getting back to the more of this enrichment stuff and the plugins. Since here you have 200 plugins and it's very easy to write your own in Ruby, this you need to write in Go. I mean, it's still easy, we provide a base library, you can totally do it, but there probably won't be a Twitter beat anytime soon. So this you will still now and in the near future do via Logstash. Okay, and since not so many have used it before, but I'm just saying it, since everything has grown very organically, all the version numbers were very unaligned. So we have, at the moment, we have Elasticsearch 2.3, Kibana is at 4.5, Beats is at 1.2, and I cannot even remember the current Logstash version. So, and the problem is, if somebody comes up to me and says, hey, what is the right Kibana version for Elasticsearch 2.1? I have no idea. And probably you need the patch level as well just to know. And since it was even for us too hard to remember that, we also decided, okay, we need another version number. And since Kibana is currently at 4.5, the next free major version number is 5. So all the products are going to 5, even though, for example, Elasticsearch is just a 2.3 with skipping 3 and 4, and it's just going to be 5. And obviously 5 is or at least sounds much more mature and grown up than 3 or 4. So this is an instant improvement over everything else. Yeah. So this is all the open source stack. You can just use all of these products today for free. We provide all the packages, and even if you want to be a paying customer, for example, to get support, you will get the same version, because many of our competitors, they have commercial and open source versions, but we don't believe in that. A, because we like open source, and B, because we're lazy. We don't want to test everything twice, because what most of the competitors then are doing, you're doing the commercial version, you're testing that properly because you're selling that, and then you're just making it worse, or you're removing features, and you're then not putting the same effort into testing that, you're just throwing that out, and people in the open source community can use that. But we think this is the wrong approach. So everybody is using these versions, and you can get support. This has historically been the only thing you could buy. The only thing was that after 1 year, people would renew their support contract, and then they would check their history and see, did we have any major issues? And then they say, no, we didn't have any major interaction with support. Why should we pay for support? Which is nice for us. On the other hand, we like to have a higher retention of support contracts. So we could make the product worse, but that's not really what we want to do. So instead, what the plan is, or what we're currently doing, we're now having commercial extensions. So these are really only plugins. You're just putting them on top of the existing products. But if you need something like security, alerting, monitoring, or we have something called Graph to explore your data, if you need something like that, these are commercial extensions, which you can buy. They always go hand in hand with support. So we can still do great products, provide good support, and people will still stick to the paid versions. And if you're lazy and want to host your own version, we have Elastic Cloud. This is currently only running on Amazon. I know Amazon has their own service. This is not by us. This is the right one to use, because A, we know what to do, B, only we have the commercial extensions, they all are provided on our cloud, and only with us you're getting the most current versions, because the Amazon version is really old and strange. Yeah. And if you're a huge customer, like some big banks and insurance companies, this will be available on-premise soon. So you have a nice web interface and you can simply say, give me 5 nodes, make it 10 nodes, upgrade to the next version. So you don't need to have any in-depth knowledge, but you have simply an interface and can use that. And I know there are always the container guys, or gals, container people. So there are the container people who say, oh, it's just a container, which might be true for your stateless application, but we're not so sure you should simply treat the database as a containerized thing, because it will be very important to always have that up and running, that you upgrade stuff in the right order, that you don't take down the wrong nodes at the wrong timing, that stuff catches up. So this might be a little more complicated than just running everything in containers. Okay, and now there is beats. So just to give you an overview, we have file beat, which I always describe like glorious tail F. It's just tailing a file and sending it over the network. Then we have metric beat. This is just monitoring your system, and you can see stuff like how much CPU am I burning? How much memory am I using? How is my disk? Like all the metrics from your operating systems on whatever service you want to use, you can run that. And then we have packet beat. It's just sniffing network packets. It's a lot like Wireshark. The only thing is, why wouldn't you want to use Wireshark? Well, if you have more than 5 or 10 servers and one request is touching more than 5 of these servers, using Wireshark is becoming quite a pain, because you need to capture packets on all of your servers. Then you need to aggregate those captures, and only then can you analyze them with Wireshark. So if you have a highly distributed system, and if you're using the microservice train, Wireshark alone is probably not enough. So what Packet Beat is providing is, it's using the same technique. It's just copying off network packets and analyzing the headers and extracting meaningful information from that. So for example, it knows you're running HTTP on port 80. So it will know, okay, this was the request, this was the corresponding response, and the response code was a 200. But the response code, was a 200. It took 90 milliseconds, and the URL that was hit was, I don't know, foobar. So you can extract all of these informations and can simply store them. And afterwards you can start. Which are my most liked URLs? Which are my slowest pages? How slow are my reactions in general? And all of these things. And if you want to write your own beats, quite a lot of people have done that in the community. For example, there is an Nginx beat, an Apache beat, a Docker beat, whatever beat. We provide libbeat, which kind of provides a low-level interaction with Elasticsearch. It can make sure that you can communicate reliably over the network. You can communicate also with queues if you want to, or if you might have spikes and stuff like that. So all of that functionality is provided by libbeat, and you can simply make use of libbeat. All our own beats are also built on top of that. Or you could use stuff like, this is called execbeat. This can simply execute some commands like a cron job. So every 10 seconds, I'm running echo with the parameters hello world, and I'm on the test host, and then I am simply storing the result, which will be not all that surprising in Elasticsearch. But whatever command you want to use to regularly run and then store the result, you can do it like that. This is community provided. Or for example, some people have lots of Nagios checks, but they do not like to use the Nagios interface. So there is a Nagios beat. So you can simply say, run this command, plugins check disk. So every hour I'm checking the disk usage, or every minute I'm checking the system load. And I can simply reuse my existing Nagios checks and export that data into Elasticsearch, where I can easily store it and then query it with Kibana. Okay. So if you want to run all of this, I have prepared a Vagrant box. You can simply download the Vagrant box, run Vagrant up, and it will configure everything for you. And I'm only using the same thing. So actually, in the Discover here, I'm ingesting the persons I have just inserted. But here are the beats. So I'm running on this instance, I'm running file beat, metric beat, and packet beat. So file beat is just reading my own syslogs. So you can simply hear, okay, from var log, auth log, whatever session closed for my user root. So I'm lazy, I'm just ingesting my local logs and analyze them. I'm gathering my system metrics, and I'm gathering my packets. And obviously the time frame last 80 years won't make much sense for the VM I've created half an hour ago. So we'll switch that here to 30 minutes. And then you can see, okay, actually here I tried some stuff, here I tried some stuff, and yeah, then I didn't do anything during the presentation, but still. In the visualization, I can either build now something to actually query the data, but we've just seen it, so we'll skip that part. And there are, for the metrics, or for the beats in general, the pre-built dashboards built, or visualizations. So for example here, I see I'm analyzing what my processes are using on the process level. So we have Java, packet beat, node, metric beat. So these are eating up most of my CPU. So Java will be either Elasticsearch or Logstash, since this is running in the JVM. Packet beat is obvious. Node is my Kibana application. And metric beat is also ingesting some data. And you have all of these different visualizations. So what you will normally want to do with these visualizations afterwards is done, that you go to put together whatever visualizations you have, you put them together into a dashboard, and that would be then the big TV screen you have in your office where you can see what is actually going on. So in this example, I have the system load, and I have here just one server. But if you had many servers, you would see all of them, and then you could actually select from which servers do you want to see the data. And then if you scroll down, you can see, okay, these are the main processes running on that server. This is CPU usage, memory process usage in general. And then you can, okay, how full is my disk? How is my file system coming along? And obviously, my Elasticsearch box is pretty full, and then you have the same metrics for CPU, and as you can see, Java is using lots of memory, Kibana is using lots of memory, and the next thing is packet beat. If you think packet beat might be too heavy to run on the same server you want to monitor, because there is obviously an overhead, what you could do is that you simply fork the network traffic over on your switch, and redirect it to a server that is just dedicated to analyzing the network traffic. So you're simply copying all the packets on the network level, and you don't burden that on your actual production system, if you think it is too heavy. Okay. And then we could, for example, take a look and see what HTTP traffic do I have and how is that coming along. So you can see, okay, these are all the web transactions I've had. So there I had a peak at 29. I'm just wondering why this is so outdated. Let me. Yeah, the time is off because that is UTC, but still the minutes are 18, so this is why we have this lag here. So actually my VM has the wrong time, so this is probably now. just that you're not confused that we're seeing anything now. So this is kind of, yeah, here's about now. And then you can see, okay, I did against this VM, in the last 15 minutes, I did 47 requests. These were my most popular URLs. Actually, these were the URLs I've just displayed here. I didn't have any HTTP errors, which is a bit boring now. Let's see. And hopefully, we can actually turn on auto refresh. So every 5 seconds the page should now auto-load. And so you can see, okay, here I have 3 404s. This is the only error code I have now. And this is when it happened over time. So I had a few 404s. If you do it, you suddenly see 500s jump up or 400s jump up, you actually see that stuff is going wrong. And you don't need to tell your application server in any form what you're doing, or you need to instrument anything. This is just extracted from the network traffic, so it can just analyze stuff like HTTP, MongoDB, MySQL, Postgres, DNS. All of these protocols, the headers are extracted automatically, and you can then simply see what is happening and what is going wrong. And you can see, okay, these are my most popular URLs. And yeah, I hope you see what you're expecting here. Yeah, so these are the basics. Since you're mostly developers, is anybody from operations here? One, okay. You don't count. So, because if you're aware of the operations people, I would know kind of jump into the configurations, but you're probably not interested in the configurations, I assume. I can show you some other features. I have here something, this is Timeline. This is actually built for time series. Time series are getting more and more important, so you can actually see how does stuff develop over time. And yes, I'm believing whatever you're trying to tell me here. And this is just showing me, okay, all the data in my cluster, how it is developing over time. And I could then, for example, say I'm only interested in the person index. So let's see how much data is in there. And okay, obviously I index that since my system time is off. Okay, let's see. Oh no, actually I'm using the date of birth here, so we would need to go back in time for years probably. And obviously if we do years, we're only interested in yearly data. So you could visualize that like that. So you can simply draw a time series. But let's switch back to minutes and actually say, okay, any guesses, do we have more metrics from file beat, packet beat, or metric beat? Any guesses which index has the most data? No guesses, okay. So what you can do is .es always targets an Elasticsearch index. And then you can simply say, for example, with index, I only want the data from one specific index. So I'm getting metric beat, and actually I want everything in a metric beat index, file beat, and what is the last one? Exactly. So, and if I run this, and now I want to switch back to minutes and on a per minute basis. No, not 30 years, that is not going to work. 30 minutes, 1 minute. And now you can see the blue thing has the most, but you have no idea which it is. So what you need to do is you can actually tell that thing, this has a name metric, this has a label name file. I know that's going to be controversial, especially if we are recording, but anyway, like in comparison to the features that Grafana provides in terms of like aggregations and kind of stuff when they interact with the feed, how rich is that? So I'm not so familiar with Grafana. Okay. The thing is, this here is not really about aggregations. This is just time series. You can do different aggregations based on a particular time series. Yeah, sure. Yeah. So, but what would be your aggregation? Some series, for instance, kind of stuff. Some series. So, for example, you want to graph all the 200s versus the 500s over time, or? Yeah. Yeah, you could totally do that. You would just need to. Okay, so first off, it is very hard to see, but here's something called research. Okay. So, yeah, pre-alpha, it's just under very active development. There are no releases yet. So all the other stuff is coupled to releases. This is just master. So whenever you rebuild this, you will get a new version, and sometimes it breaks. I had broken versions every now and then. The guy who wrote Kibana in the beginning, Rashid, he is now working full-time on the time series stuff. So it is getting quite a lot of love, and it gets more cool features. I can dive in a few features in the next few minutes. But the general idea is you have data in Elasticsearch, or you can also get data from external sources. And you can display it like this. And you, of course, can limit it down. So instead of just the index, you could just say, okay, give me from one index a specific type, or give me just where one field matches something. So you can, I wouldn't really call it aggregation, because this is just filtering out the results you want to graph. Okay. So if I run this now, you can actually see, okay, metric beats are producing the most log files. All the others are pretty quiet, but we could, for example, exclude that one, and then you can actually see that the others are still in action. And actually, I can make this bigger so we're not just using that little space. And what is also pretty nice is that you can use external sources. So this data has all been living in my Elasticsearch cluster. But I can also get in data live from external sources. I don't have them locally, so the Wi-Fi should hold up. So for example, there's an integration into the World Bank data. And you can simply get, for example, the population of Germany and graph it out. But again, not 30 minutes, but let's take the last 100 years. I think they have data for that, and then it would tell me, okay, 1 minute is not good, so we are going up to 1 year again. And then you can see, okay, data is probably not that good, so we could limit that down actually to 50 years only, or 55 or whatever it is. You can see, okay, population of Germany has grown quite a bit. And then you could be interested in like, okay, how is the population of, I don't know, the Ukraine doing? I haven't tried that. UA, oh yeah, thank you. Hope this is working. It's shrinking. Ah, people have been going back. Okay, but this is pretty hard to tell, like how the development is actually. So what you can do is then you can wrap the thing in another function, and I just want to see the change over year. So if I run that now, you can actually see, okay, this would be 0, and you have, so the Ukraine has just dropped below 0, and Germany has some weird outliers here. Whatever is going on. And now that you mentioned Russia, we could see like how is Russia doing in comparison. Is it RU? Yeah, it's also dropping and it's growing again. And if we want to see the absolute numbers, let's see what they look like.
So pretty good support. You have like derivatives, you have absolute numbers. So
yes, there are some functions you can use. And so absolute, you could, yeah, we could draw this as bars, for example, even though this, I'm not sure how much sense that makes. But you can play around with colors and lots of different stuff. So yeah, you can do funky stuff. You can do conditions, yeah, and more stuff is coming like all the time. You have moving averages. You can multiply specifically. For example, you could say, like, I want to multiply the people of the Ukraine, since it's the smallest country, by 2, and just compare that and do other stuff. Some interesting comparisons I have seen was like somebody got in the stock price of beer companies and graphed that and compared that with the amount of beer sold on a monthly or weekly basis. And you could see that the stock prices of beer companies and how much beer they sold actually correlates pretty well. So if people are drinking more beer, the stock prices are going up. This is just the stuff you can very easily do and put on a big dashboard in your office and just show off, yeah, we're doing well on this, we're not doing so well on this. Yeah, time series are becoming a very popular topic. So there are yeah, Grafana is for the visualization one popular option, but there are others also like on the storing side. Since most of you were in the Elasticsearch talk, just one other information. If you think about Elasticsearch and the inverted index, it does sound like this wasn't well suited for time series, because it's always about like you're looking up one term, and then you're seeing, okay, this is a hit on all these documents. And this just doesn't sound like it is doing a good job for time series, because with time series, you're just interested in kind of, if you would try to think of it as a table in one column or like one field name. So this is why Elasticsearch in the previous version added a columnar data type. So this data can be extracted very efficiently as well. So this is why it is actually possible to do that in Elasticsearch. And of course, since everything is Lucene, all of that, the underlying information is coming in Lucene. So every time we need to add some feature like that, we have lots of Lucene core committers. Somebody needs to start the work in Lucene, then there's a Lucene release. And at some point, we can package Lucene release in Elasticsearch and do a release with that. So there's normally some lag, but there is more cool stuff in Lucene coming that will only surface like in the next year or so. Yeah, so these are time series. I think this was pretty much it. So just to do the conclusion, this is the stack. I didn't dive into the configuration files, but on the next slide I have the URL again. You can see all of the configurations, how you can use them. So you can just dive into that and ping me if you have any questions. The general idea is, Beats are the lightweight forwarders or shippers. They will just get the data. They don't do any parsing. They will just forward stuff. And for the system metrics, that's already then available in JSON. You can store it directly in Elasticsearch. Some log files, for example, you will need to parse, and that is what Logstash can do. So your Beats will forward the logs files, and it needs to be parsed, like told, this is the timestamp, and this is the HTTP return code from an Nginx log, for example. And all of these informations, you can do that parsing and enrichment in Logstash, store it in Elasticsearch, and then Kibana do all the visualizations. And Timeline is currently the only thing that is not in the main line of releases. It's a research project, but at some point in the near future, I hope, it will become stable and is then generally available just like all the other products. And yeah, if you want to give it a try, this is the URL where you can get it from. And that's kind of it. I've got very few stickers left. If you want some stickers, come to me. And are there any questions? Questions? Anything you want to see or try out? Oops. Any more questions? So everybody is dead after a long day? Pretty much okay. I'm just bored out of interest. Whatever the... that is currently... Okay. Looks like the US are more popular than all the other countries. We could see like the derivative, what that looks like. Either the data is for that year or the US have a serious problem, but I guess they just didn't tell any proper numbers for these years because it's just 0 here. But yeah, you can see, I think like the only country that is growing like crazy are the US, and all other countries are rather losing or just population or just holding up. Yeah, so you cannot only do serious stuff with the Elastic Stack, but you can also play around with data and compare. Yeah. Populations, gross national product, stock rates, all these things. Good. Any questions now? Or we're done? Okay, we're done. Thanks.